Today I'll be doing the LeetCode question task scheduler. I've been avoiding doing like an interview style LeetCode question for the longest time. I kind of just like do it quietly, and that's because I'm so goddamn scared. Like, I guess a part of me wants to get so goddamn good at doing LeetCode that I want to be good enough so that when I do talk, it's like it flows like butter. But I think that way of thinking is so fucking flawed, because how am I ever gonna get so goddamn good if I'm not practicing the skill of verbalizing my thoughts? So I'm gonna practice doing a lot of these more often. I'm also gonna be recording myself just for that extra little pressure. I'm doing this alone. Normally I would do this with a friend, but it's fine. I'm gonna post this shit to YouTube and embarrass myself trying to do a goddamn LeetCode question for like 40 minutes or something. But it's a necessary process. So let's do this. Shout out to this guy called John Wilkins who is like basically doing this every day, and it's been like close to a year for him now. Mad fucking respect. That's the level of discipline that I want, bro. But yes, I want to make this like a more consistent thing with my schedule. So today we're doing task scheduler, and the reason I'm doing this is because a friend of mine who got a like Google on-site interview had this question, so I figured it might be a good way of just practicing it. So let's do just that. I'll try my best to avoid looking at the hints as much as possible. If I can't, yeah, I'm screwed. So you're given an array of CPU tasks, each labeled with a letter from A to Z and a number n. Each CPU interval can be idle or allow the completion of one task. Task can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals between two tasks with the same label. Return the minimum number of CPU intervals required to complete all tasks. Okay. So there's a tasks labeled A to Z, and the number. A CPU interval can be idle or allow the completion of a task. They can be completed at any order. There has to be a gap of at least n intervals. So CPU intervals. So A, B, 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 n equals 2. A possible sequence is AB, idle, AB, idle, AB. So this is the idle period, I'm guessing, right? 2. So AB, AB, AB. After completing task A, yes, we're waiting for the second interval, and it's just like how long this would be. So 1, 2, 3, 4, 5, 6, 7, 8. Wait, I'm doing this wrong. What is n equals 2? What is that supposed to represent? There has to be a gap of at least n intervals between two tasks with the same label. You must wait 2 intervals. Okay, I see. So I did A, and now I can't do A for 2 more, so that's why I'm doing B. So it's idle, and then A, B, idle, A, B. Okay, so that's in total like 1, 2, 3, 4, 5, 6, 7, 8. And this one, it has an interval of 1, so it's basically just, you know, the input itself, right? 6. This one is probably a bit harder. A, B, idle, idle, A, B, idle, idle. Okay. Question is the input sorted? Okay, no, it doesn't look like it. So it's like A, B, B, AC, A, B, D, B. It's like, doesn't really matter. But it makes me wonder whether I should sort this. Like, if I sort this, then I would know, you know, there's like 3 A's, 3 B's, because if I do this, I can do A, but then I don't know, you know, when an A is gonna pop up again. A might be at the very end, and I could better optimize it. So my first instinct is to sort this tasks.sort. So now this should be in the correct order. Now n matters. What data structure can I use here? maybe a something to keep track. So I need to keep track of the letter that I used and the interval. How would I do this though? So I do like A. So let's say we have this, okay. And it's like, how would I know? How would I know like what to put in anyways? Like the order. Wouldn't it be better if it's like mixed? Because then I can do like A, B, A, B, A, B. Because if it's like A, B, 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 I'm kind of screwed because now it's just a bunch of A's, right? Dude, LeetCode doing a damn good job and make me feel like a goddamn idiot, bro. Okay, I'll set out like if it's 12:50 and I do not have any idea of how to approach this, I might look at hint 1. But let's see here. Is sorting even the way? What if I had 2 pointers? Let's go on a whim. 2 pointers, one at the front and one at the back after I sort this, right? Well, is that gonna matter? It's gonna be like this. And it's gonna be at A and it's B, and it's like A, B, A, B, A, B, A, B. What if it's like A, B, C? It's just gonna be like the same one. Maybe I should like put this in a dictionary with a counter, huh? Because then that might be better because now I know how many tasks there are for each of them. And then if I have like a dictionary with the count, how would I know the intervals though? How would I even store this? What variable, what data structure do I want to use? Like a list. AB, idle AB. Like how would you keep track of, so I need to keep track of like, okay, say I push in A, boom, A's in. Now I need to keep track of the interval for A. And I also need to keep track of, you know, like say I have the list, like the dictionary. We used A, don't use A now, use something else. Maybe a set. How would I know? How would I know to pick like another letter instead of A? Like B, how would I know? How would I know? What the hell, bro? Fuck, bro. Do I loop through it? Do I like have a fucking dictionary and just loop through the dictionary? No, like a set, loop through the set. Oh, 1 month of LeetCode and I'm still lost as shit. I don't even know what data structure to use, bro. Okay, whatever. N equals to 1. I just need to keep track of like. Okay, whatever. How would I keep track of, you know, the interval and like the letter A interval? It's like, yeah, the condition would be if n is equal to 0, right? Then you could use that again. But how would you associate n with A, for example? How would I associate that, okay, a letter is free? A Q maybe? Like a stack? Keep track of like, it would be like, okay, A, I pushed A, it has like a interval of 2. And then I push B, it has like an interval of 2, but now A is like 1. You know what I mean? How would I do this? Oh, I pushed C, and it has an interval of 2, but now it's 1 and 0. How would I do this? And how would I even like add in all these letters? I'm lost. It's 12:50, so let's look at hint 1. There are many times. including a greedy algorithm. What does that mean, bro? A greedy algorithm. How would I be greedy with this? I don't even know, bro. Okay, let's say, let's be greedy. Like, what if I go through this list, A, and like, okay, I push A, and I have an interval of 2 for A. How would I even know that, though? That's the thing. How would I check this? Okay, straight, hint 2. For every cycle, find the most frequent letter that can be placed in this cycle. After placing, decrease the frequency of that letter by 1. So it is a frequency thing, right? So I would probably need count, I think, for task in tasks. For I task in enumerate tasks. Count I, the index. The index doesn't matter, bro. I can just do like for, I think I can just do like for task enumerate here. Enumerate tasks. Count task is equal to 1 plus count dot get task. But if it doesn't exist, then we're gonna put in a 0. So now we have a count of everything. I don't know if that's the way to go, but now we know it's like 3 A's, 3 B's. I can kind of do that. 3 A's, 3 B's. But like, how do I know that to use it? For every cycle, do I kind of just go through it every time? While? Do I use a while loop? But how would I keep track of, you know, while count? Is that how it is? I don't know, man. Hint 3, use priority queue. Bro, I don't even know how to use a priority queue. Fuck, bro. How do I use a priority queue, bro? Alright, I'm gonna use GPT just so I know, like, like the fucking syntax for this shit, bro. I mean, I know it's like first in, first out, but I don't know how to create a priority queue. What if I use a queue and I push into the queue, but, you know, depending on what n is, we put in like dummy numbers, bro. So it's A, right? What if it's like not, if it's n is equal to like 2, I would do like none and then the number, and we can just like push out every single time. Bro, I'm so lost, man. Dude, I am actually so goddamn lost. I don't even know how to approach this question in the slightest. Like, I feel like a goddamn idiot, bro. Priority queue. Fuck, bro. Dude, I'm actually so lost. I don't even have the intuition, dude. Oh my god. Oh my god, bro. Alright, fuck it. Task scheduler. Can't type. NeetCode. Let's just hope NeetCode has a video on this and then we can do it. Oh, nice.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem task scheduler. One of you suggested this problem, and I think it's a pretty good one. So we're given an array of tasks. It's a character array.
Okay,
so that's this that represents the same one times we process a B task. Wait A time. There's a B as well. We know we actually have to wait 2 units. Another B will question is time. 2A of time. B the next half tasks we were looking for 3 A's and 3 B's. So as you can see, it took us 1, 2, 3, 4, 5, 6, 7, 8 units of time to do this. So our output is going to be
what
A.
if I make a list that's like super, like the max possible number, and then like I leave some values blank, and then I put it in depending on like what I
So now let's think about a general approach that we could come up with to solve this problem.
I
So
actually
let's
feel
say
like
we
an
had
idiot.
this as our input. First thing to notice is we're going to be given characters A through Z. It doesn't really make sense to worry about which character we're looking at, right? There's really not a big difference between a B and a C, but we should keep track of how many of each character there is. So we know there's 3 A's, 2 B's, and 2 C's, right? We don't even have to worry about the characters anymore. We can just focus on the numbers. We know that there's 3 of one character, there's 2 of a different character, and then 2 of another character. We know that the idle time in this case is 1. What order should we process the characters in? It's probably better to process the more frequent character first, the more frequent task first, because we know there's going to be some idle time, and processing the more frequent one first basically gives us more time to not be idle. And I'll show you the intuition behind that. Let's say we did a C first, right? We do C, we know that the idle time is just 1, right? So then let's say we do B, and we're allowed to do another C right away. Let's say we do that, right? We do another C, and then we do another B because the idle time is only 1, right? So now we've already processed all the C's and the B's, and all we're left with is 3 A's. Okay, let's process one of the A's. Okay, great. But now we have an idle time. We have no other characters available for us, so we have to wait. And then we can process another A, and then we wait, and then process another A. So in this case, this was one way, but did this minimize the total time that it took us to process all the tasks? A different way would have been to start with the most frequent character, right, A, and now there's only 2 A's left. So now what's the most frequent? Well, you could say A again, but we know that there is an idle time of at least 1. So at this point in time, A is not available to us. So we have to process a different character. That's the A of the 2 A's and unit rather than this one. And what is the idle time in this case? It's about, not the idle time, the total time in this case is about 7 as opposed to 9 in the other case. So that's kind of the intuition why we're going to try to do the more frequent task first, and then the less frequent task. How we're going to be doing this is by using a data structure called a maxHeap.
Bro, I don't even know how to create a maxHeap in Python,
Python,
bro. I'm so cooked.
The most frequent one, and the maxHeap can actually allow us to determine that in log n time. Right, if we have a bunch of these, we could figure out which is the most frequent in log n time, which is good. But in this case, actually, it's even better than that. It's about log 26, since we only have 26 different characters. This is kind of a constant time operation anyway. But I will say that the overall time complexity is still going to be big O of n. One, because we are going to have to, count the occurrences of each task. So we're going to have to go through the entire input. And we're going to be, popping every value from our maxHeap and adding every value to our maxHeap. So the time complexity is going to be big O of n. That's also going to be the memory complexity. But now to the actual algorithm itself. We're actually going to use one other data structure, a queue. It's not required, but I think it makes the problem a little bit more organized. So let's start off with the maxHeap, right? We have 3 integers. We're going to be adding integers to our maxHeap, not the characters. We're going to be taking the counts of each task and adding that to the maxHeap. So we're going to have a 3 and a 2 and another 2. And by the way, when I actually code this up in Python, we don't have a native maxHeap. So the way we only have a min-heap, so the way I get around that is basically by taking each of these values and making it negative. In a maxHeap, we want to pop the maximum, and we can do that in log n time. So in this case, we'd pop the 3, which is the maximum. But in Python, we're actually going to do it the opposite way. All of these are going to be negative, so we're going to end up popping the minimum, which is going to be -3, but we're going to, assume that it's a +3. But yeah, so that's the idea. First, we're going to pop the 3 or the -3. You can think about it however you want. That's the most frequent, but now we want to change the count from being a 3 to now being a 2, right? Because we just processed one of the tasks. So, if you have a negative, you'll have to add 1. If you have a positive, you can decrement it to 1. In my case, when I write the code, I'm going to be adding 1 to this. But now we're actually going to be taking this and adding it to our queue data structure, because we know that there's some amount of idle time for this task. At the current point in time, we are at, initially we were at time equals 0, but we just, or -2 to our queue. But we're also at this integer, but we just processed the task. So now we're at time equals 1, and we're going to add this integer 2 or -2 to our queue, but we're also going to be adding another value to the queue. And that's at what time is this task going to be available for us to process once again. Basically, at what point can we take this and add it back to our max heap, right? What's the idle time that is going to be remaining? Well, right now we're at time equals 1, and our idle time for each task is n equals 1. So basically, we're going to take n and add it to our current time. So it's going to be 2. Basically, at time equals 2, this task is going to be available for us to add to the heap again. So that's what the second value in this case means. And once again, we're going to pop from our max heap, we're going to pop the -2. And that means we have processed the task. So now our time is actually going to be time equals 2. We're going to take that task. It was a -2. We're going to add 1 to it, which is going to make it a -1. So then we're going to take that -1 and add it to our queue. And at what time is that task going to be available to add back to our max heap? Well, it's going to be 2 plus 1 because n is 1 in our case. So at time equals 3, this task can be added back to our max heap. But now that we're at time equals 2, we see that this task actually is available now to add back to our heap. So let's pop it from our queue and take the -2 and add it back to our max heap. And at this point, you're probably starting to get the idea, so I'll just kind of fast forward through this. We're going to pop this again, set our time.
Okay. I kind of have an idea of how to do this now. Okay, so all we care about is values, right? Count out values. -1. Okay, so we're gonna put in negative numbers for the count. So like that's all that matters. So it would be like -1 -1 -2. Yeah, that sounds about right. 0 -1. Yep. Okay. Count task. Count.get task. Blah blah blah. We don't even need enumerate here actually. Okay. So I think this is how I heapify. Let me actually just ask how to make a queue and min-heap in Python. I think that's how I do it though. Count, right? Count.values. It's gonna be negative. And I'll also make a queue and time, which will be 0 initially. How do I do this though? While heap queue. I'm sorry, bro. I do not know how to make a queue in Python. Let's just do min-heap. Heap queue dot heapify array queue dot I think it's like min-heap count out values or something. I think this is the right way of doing this, bro. Just gotta GPT this shit, bro. Just make sure that I have the right syntax. Okay. I think the condition here, though, is while min-heap, I think min-heap dot Time matters? I think time matters, bro. heapq.hiphop. heapq.hiphop. Okay. min-heap dot min-heap dot heap dot heap hop. Oh damn. Fuck. Heap q dot heap hop min-heap. That'll give me the value minus equal 1. This is like q dot do I want to advance the time forward? Time plus equals 1. No, I want to do that at the end, no, because right now we're still at 0, right? So how do I want to do this? Okay, wait, actually, let me move because my laptop is dying. I need a better way of recording, bro. This feels so ghetto. Hey Siri, kitchen lights 30%.
Sorry, some
Yeah.
accessories didn't respond.
Okay, good. Val is heapq.heappop. So I'll do -1 now. Task. So now I can do like q.push or a pen, I guess, right? Task. I'll make this a tuple. Task time plus n. So at that time interval, it'll be ready. And then time plus equals 1. But that's not right, I'm pretty sure, because I need to check if q0, if q and q0 is q01 is equal to 0, less than or equal to 0, right? Then q.pop left. Pop left, yes. If q and q01, which is the very first. Is there like a better syntax for this, by the way? No, just peek the top, bro. If q and q01 is less than 0, then we can q.pop left. Q.pop left. This is the value we popped, by the way. Heap q.heap push. This value. Pop left. But the first one index, bro. Or actually the 0 index. Because this is the time. Oh shit. So time plus equals 1. Okay, so time will move forward after this. This is not right, bro. Yes, that's better. I don't know if this is the condition. Okay, say we pop everything from the queue. Okay, so we have everything in minHeap, but let's say we don't have anything in minHeap because it's gonna be 0. if task equals this task q dot append. Yes, because it's greater than yeah. If task is not equal to 0, let's just do that. Because if it's 0, then like we won't need to append it to the queue again because we're done. Time plus n. If q and q01 is less than time, then we can keep going. Should I make this nq? Will there ever be a situation where min q is empty and q is not? What would I do then? Say it's these two, and it's like 3, 3, or let's just do 1, 1. I push 1, 1 is done. 1 is in the, okay, I'm not sure what the while condition loop is. So let's say there's 1a and 1b, okay? In the min heap, right? It's gonna be like -1, -1. So now we have the queue, which is empty. But okay, we push this, which is now done. Which is 0, so now we're done. Queue is empty. But okay, actually, let's do -2. I think that might be better. So we have -1 right there, right? This is gone. -1, like 2 or some shit, bro. -1, 2. So -1 would be the how many more A's there are. 2 would be, yeah, we're gonna have to process this when time is 2. And we still have this. So now we process this, put that at the end. It will be like done. So you won't even need to add that one. But this is still countdown, bro. So it's like we still need to add this to the queue. If heap this may be it, bro. So I'm just gonna test it out. Screw it, bro. I'm gonna be wrong. Fuck. Heap is not defined. Oh, sorry. Min-heap. If min-heap. Okay, let me just double check that I have everything. Heap. Just double check the syntax. Okay. Count the values. Min-heap. Q. Is it heap push? Heap push. Okay. Q dot top left. Bro. I'll just do this. From collections. DQ. Maybe I should do that. She. DQ. Is this how I do it, dude? should add that. This queued up uplift. Something's wrong, bro. What is this error? Expected 2 arguments. Oh, heap queue push. Is it like min-heap? Like that. Time limit exceeded. Fuck, bro. Okay. I'm just gonna print heap and min-heap. Q, and we'll see what this shows. Actually, let me just add time as well, just to kind of like showcase this, bro. And actually, initial. Let me just do this. Print initial heap, and then I'll do min-heap. There you go. Just for that extra flair, if you will, just to make sure I get everything right. So initial min-heap is just -3, -3. Heap is -3, yes, because I dequeued this. Oh, okay, so this should be +1. Oh my god, bro! Oh shit! Output exceeded. Fuck. Oh fuck, wait, what the hell did I do wrong here? Oh no. Oh shit. Fuck. Okay. What is this button? Analyze complexity. Whoa! Oh my god, I did O of N though. What the hell? Why does it say output limit exceeded? Okay, wait, do I need to get rid of this comments maybe? I don't know if this will make a difference, but I'm just gonna try it out, man. Submit that shit, bro. Whoa! Holy shit! I fucking did it! What the fuck, dude? I've never felt more happy in my fucking life, dude. Holy shit! What? What? Dude, this is crazy. Okay, dude, oh my god, I'm gonna fucking go on a fucking victory run. Woo! Let's go. It has a time complexity of O of N. Why? I don't even know, bro. I don't even know why this shit's O of N. What the fuck? Okay, but I really should figure out why it's O of N though. So, okay, I am like building this into an array. So that's already probably the O of N, right? And it has a time complexity of O of N, which comes from just heapifying it and like building the counter. Like when you add stuff to the, like when you're pushing or popping from a min-heap, it's like log of N. So it's not taking up a lot of like it's not super complex. And same thing for Q. So it all kind of adds up to O of N. Woo! Dude, this is actually crazy. Oh my fucking god, bro. I'm actually going crazy, bro. What's this shit? Okay. Dude, it's actually insane. Oh my god. Space complexity, bro, I don't even know. It's probably like O of N. Like, I'm gonna just be real, bro. Let's go. Oh my god, bro. This is actually crazy. Oh my goodness. Oh my god. I'm actually so fucking hyped. This is the start, bro. This is the beginning. Let's fucking go. Okay, good job, me.